All right, so we're going to go ahead and get started. Um, we are finishing up chapter 2. So if you have not read chapter 2, definitely work on that because we're looking at reviewing Monday and testing on Wednesday. Um, so, scatter plots, correlation, and regression. So, these are things that if you took not a calculus, an algebra 2 course in high school, you probably looked at some of this. Depending on when you were in high school, you may have even done this in algebra 1 and even some before that because you really, in lower grades, they sprinkle in a lot of this, the graphing vocab and all the things. I'm gonna turn my camera off. All right, so key concept. We want to introduce the analysis of paired sample data, and what I mean by paired sample data is that we have an x and a y, um, and that can have create a coordinate on a coordinate system, a coordinate plane. We can graph our points so that we can look at a scatter plot and determine a trend. What I mean by trend is what type of correlation we have. We want to talk about the correlation and the role of that graph, which is called a scatter plot. And we want to discuss a linear regression, which is also known as a line of best fit. If our graph is more of a quadratic trend, which means it goes more of a curve, it's thought of as a quadratic regression, and that then you might relate the terms curve of best fit. Um, but a correlation exists between two variables when the values of one variable are somehow associated with the other. So sometimes there is no correlation. If we see our graph kind of scattered everywhere, there's no trend, there won't be a correlation. However, a lot of times we'll see a positive trend or a negative trend, meaning it goes, it's in as x increases, y increases for a positive, and for a negative, as x decreases or as x increases, y decreases. So, a linear correlation exists between two variables when there is a correlation, and the plotted points of paired data result in a pattern that can be approximated by a straight line. Excuse me. A scatter plot or scatter diagram is a plot of paired XY quantitative data with a horizontal x axis and a vertical y axis. Now, we are going to look at what this looks like um, in a graph today, and then you're going to take a couple tables from the text and create your own scatter plots and identify some things about the scatter plot. All right, so if we look at these two scatter plots here, we can see that we have a positive correlation for this one on the left. If you notice, all the points are trending upward from left to right. On the right graph, all of our points are trending downward, which has a negative correlation. Now, you see here this R. The R right there identifies our correlation coefficient. And the closer that is to 1 or -1, the stronger the correlation. That what I kind of think of when I think of that is that the tighter the points are together, the stronger that correlation is. If you look at the one on the left, you see they're definitely trending. Excuse me. They're definitely trending upward. But you see how they're a little more dispersed, further apart from each other than graph B. Graph B, the points are like closer, tighter in together. So that's a stronger correlation. Now, this example here is that of something with no correlation. So this is not going upward or downward. It's has no trend. There's no correlation. And if you notice, the R here is 0, meaning that there's no correlation, because your correlation is going to be somewhere between -1 and 1. And so in the middle of that is 0. That means no correlation. As your correlation coefficient goes to -1, that is a strong negative correlation. As your correlation coefficient goes towards +1, that tells you it's a stronger positive correlation. Oops, I didn't mean to do that. All right, so you've heard me talking about a correlation coefficient. This is what it is. It's the R in this case, and it's the linear correlation coefficient. It measures the strength of the linear association between the X and Y, between the two variables. So this is what I have kind of said, is that the closer you are to -1 or 1, the stronger the correlation. The closer it is to 0, no correlation. So now, this is what you want to pay attention to, because you're going to have to do this. So in Desmos, you are going to type in a table, and we'll talk about how to do that. This table's already in, but if it wasn't, what you would do is in Desmos, you would click the plus sign, table, and put in your data. Well, it's already done, so here's my data. Looking good. Now, my data. Now, when you first put it in, it's going to look like this. And you can tell, oh, this is a positive correlation. And some of you may be like, how do you know that? Well, one, when I look at the graph, it's going upward. Positive correlation. Also, when I look at my correlation coefficient, so if I type in correlation x1 comma y1, it'll tell me my correlation coefficient. And in this case, it's a positive. That's first good thing. It's also pretty close to 1. Now, it can get much stronger. Like, you could get a correlation coefficient that's like 0.99 or 0.98. Anything obviously over 0.915 would be a stronger correlation. So one way to find the correlation is to type this in. And so you're going to have to put data in, find out the correlation coefficient. That's one way. The way I like to do it, sorry, I have my computer kind of like up on a thing so like I can fit my papers and binders under it. So I'm kind of like reaching. I feel like I'm reaching up to be able to type this in. So I could also, where did my stuff go? That's weird. All right. Oh, that's the problem. You don't use the equal sign. You use the little squiggle. I can't believe I forgot that. This is the formula for slope-intercept. And this is what actually gives you the line to show you your linear regression. But also within it, you can find the correlation coefficient. The key here is when you're typing this in, which I cannot believe I forgot, is y1. Instead of an equals, you use the little approximately mx1 plus B. And that gives you your line. But again, if you just want to type in core x1 comma y1, that'll also give you a correlation coefficient. Now, some things I want to point out about this x1 y1, and here the x1 and y1, that only works if in your table you have x1 and y1. So if I was to go and I'm going to, like, say I was starting my own graph, my own table, and say I was to put in a table, and I put in my information. Say I was to put my information in, and then I was like, oh, I want to do another table for my next one, and I was to put in my information. All right, so I put my information in, and then I was like, okay, I'm done with that one. Now I want to find my correlation coefficient, and I type in correlation x1 comma y1, and I'm like, oh no, it didn't work. Well, it's because in my table, I'm not using x1 and y1. So you can either change this in your table or change this to x2, y2. And then that gives you your correlation coefficient. You also works the same if you use your slope-intercept form, and you see that's a super strong correlation coefficient because it's 0.98. So with that being said, the number with your x and y has to match what's in the table. So keep that in mind. Now, some of you may be like, I've never used Desmos before. That's fine. If you don't have to use Desmos, you can use something else if you prefer. A any graphing calculator. I choose Desmos. One, it's free, so I like it. And also, two, I taught in Virginia schools prior to at the collegiate level, and that's what we use. So it's what I am familiar with. And if you went to a Virginia middle and high school, then you've used Desmos as well. And if you didn't and you struggle with it, you have options. You can use something else that you're comfortable with, or, we can set up a time to meet and I can walk you through some things with it. So we see this example here. This tells me the arm span and the height. In this case, the arm span is our x coordinate. The height is our y coordinate. Looking here, is this a positive correlation or a negative? Positive. You can tell because it's from left to right, it is going upward. I have my pen connected, but it's fine. All right, so properties of linear correlation. I'm not going to read all this. It's it's all the stuff I already have said. This is way to see kind of if your critical value, if your R is between negative 0.8 and positive, that's really not a good correlation. It's pretty weak, even though we think, 0.8's pretty high. When you look at a graph and if the R was that low, your points would be pretty spread apart. And the whole idea here is to be able to have things that are trending in a particular way so that we can make strong and confident decisions based on the statistics that we found. So we do want to make sure that when we make a claim, that it had a strong correlation, whether it be a negative or a positive correlation. We don't want to sit around and make claims about things that are not solid. So we'll talk about p-values later in the semester, like a lot. So if there really is no linear correlation, the p-value is the probability of getting the paired sample data. Um, and so again, we're not gonna talk about that right and work with that right now. We will later. And so regression is given a collection of paired sample data. The regression line, which is the line of best fit, is the straight line that best fits the scatter plot. So, again, most of you have probably worked in some realm with scatter plots, linear regression. If you took Math 103, you guys did um, linear regressions then. So there's that. So this is the regression equation. Now, I put ax plus b here. When I first started doing this, not all calculators use the m. Some still use a different variable for the slope. Again, that's just whatever works for you. But these are the two common regression equations. If you remember from another time of math, the m represents the slope, which is the steepness of the line. If your slope is positive, then your line is increasing. That would have a positive regression. If your slope is negative, then similarly, the line is decreasing. Your slope is negative. It is a negative correlation. And then the B represents the y-intercept, where it's closest, like where it crosses the y-axis. So again, it's just another place for you to see the regression line here. And so this is really good if you want to look at this as an example when you're doing your homework problems. Again, make sure whatever number is attached to your variables in the table is the number you use when you create your line of fit or identify your correlation coefficient. This things I just talked about. All right. So, important here, being able to interpret our scatter plots. So, this says, the scatter plot below shows the average traffic volume and average vehicle speed on a certain freeway for 50 days in the year 1999. So, when we look at this, is this scatter plot positive or a negative correlation? Negative. So it's a negative correlation, which means as the x increases, the y value is decreasing. So as the traffic volume increases, the vehicle speed decreases. So we need to choose which one of these matches our table or our graph. So when I look at this as the volume, that means as there's more people on the road, then people's speed decreases. So looking at this, it would be letter B. Does everyone, does anyone have any questions on that? If so, just be like, can you explain it? All right. So good. And I always wonder, like, why this is. I guess maybe it's just busier and people seem to slow down. Um, I don't know if any of you run into this, but like when you're driving down the road and it's like you almost get to a standstill and you're like, oh, there must have been a car accident or something. And then, like, it was nothing. And you're like, why? Like, what just happened? I don't know. It blows my mind. Like, why? Why is everybody like stopping? Anyway. All right, Miss Ocho recorded the age and shoe size of each student in her physical education class. The graph shows the data. Would you say this has a positive, a negative, a constant, or no trend? I would say no trend too. Um, and it's kind of ironic because you would expect the older students to have, it to be increasing. But I look at the age range she chose, and I feel like 11 to 14-year-olds, also you have to take into account, there's female and male. And I feel like I can see why it would be all over the place. However, if we had like said, okay, I want to look at the age of like females, and we looked at just female students, and we changed our age range from like 0 years old to 5, I think we would then see a positive trend. Personally, I would never expect to see a negative trend. Most people's most people's feet do not shrink. I say most because it can happen. But in this case, I would say there's really no trend here. All right, looking here. The police department tracked the number of ticket writers and the number of tickets issued for the past 8 weeks. What conclusion can you make based off the scatter plot? So, looking at this, can anyone tell me a conclusion you would draw from the scatter plot? Yeah, the more people, the more people writing tickets, the more tickets there's gonna be. That's, I feel like I would expect that. All right. This says, this says a fifth grade class conducted a 5-minute experiment that involved heating time and water temperature. The results of the experiment are represented in the line graph below. So, what prediction can be made based on the information? Yeah, and don't we kind of expect that? Now, do we expect that maybe after a certain amount of time it would level off? Yeah. Like if we kept looking, I doubt like, I feel like it's only going to get but so hot. So, um yeah. Um the scatter plot shows the number of absences in a week for classes of different sizes. Trevor concluded that there is a positive correlation between the class size and the number of absences. Based on this visual of the scatter plot, do you agree or disagree? Yeah, like I feel like if we only had like this one dot and these down here weren't there, we could say it's a positive trend. But we have too many points that, in my opinion, would be outliers to say that it's a positive trend. I would probably say in this case um it's not really a positive trend. I'd say there wasn't a correlation. However, in my like personal experience, I think there is probably a correlation, but we have to go based off the graph. All right. So, what type of correlation would you expect to see for the number of hours studied compared to the scores on the statistics test? Positive trend. The more you study, the better your score. In the- Anyway, sorry. My kids are home. So what you're going to do is use problems 11 and 12 to create a scatter plot and find the correlation coefficient, and upload your answers to Canvas. Um, so if you don't have a textbook, I have uploaded, I think, yeah, I uploaded a picture. This though may be from I don't know if this is from the old textbook. So if it is, if this, I don't remember if this is from the old or the new, but if your textbook has a different 11 and 12, then you can use that or you can use these two graphs. I will check it based off what you used. All I want to see is that you can put the scatter plots in Desmos. So what I mean is you would go in Desmos, you would create a table, and you would put in your data for number 11. Once your data is in for number 11, you would do correlation. Oh my goodness. X1, comma Y1, and you wouldn't put uppercase. And of course, it's saying undefined because I don't have anything in here. And it would do my scatter plot. Then, you would want a screenshot or write down your correlation coefficient, whatever, so that when you go to submit this, you're gonna have to put like number 11 correlation coefficient R equals blah blah blah. Number 12 correlation coefficient blah blah blah. So you'll just submit that. With that being said, that is what is due by the end of Monday. Now, because we've kind of missed, I do just want to go over some things that some of you may have missed that you need to be doing. So, chapter 1 quiz, I graded that. That's in. If you did not take the chapter 1 quiz, then we need to do that. You'll have to get with me. Then frequency distribution notes. If you had clicked on that, oh no, we did these together Friday. Yep. Then the histograms. There's a video there that you really should watch. Also read the chapter. Then there was an assignment, and it looks like only 4 people did the assignments. Make sure you do the assignment. What it is, actually, more people might have done it. I might already graded the more. Anyway, so you can do this on a separate sheet of paper and upload your answers. Normally, we would do that in class, so you're kind of, everyone should do well on it. Then there was a video on graphs that enlighten and deceive. Read in your textbook, watch the video. This is the video. I recorded that like a year ago because we had snow the last time I was supposed to teach it. Scatterplots, that's what we did today. I will also upload the video, but then you have this assignment to